So this is the what we call the vignette of the package. Okay, so it's called financial math, and okay, so if you come to the content, you find amort.period, amort.period, then it's about amortization, right? Okay. So we can even give you a loan, you can check the repayment period, annuities and so forth, evaluate them and a whole lot. But this is not a financial math class for me to go through. My job is to now teach you that you can have a function like this, you can get a package like this, and this package can do this work for you. It is up to you to, explore most of this. Nobody can teach you a programming language for you to be an expert. The rest depends on you. But you must get a basis, and then you can build upon it. Okay. So the idea is to teach you the basics so that when you find yourself anywhere and they have any package that can be used, you can actually implement it. Okay, so you can go through and check. So there's NPV, IIR, IRR. So that's 28, 29. You remember perpetuity. Okay, so many things in this. Swaps, yield, TVM, what have you. Okay. So, and any function that you find in there, it gives you a description of it. So, for example, if we use the function amort.period, it says what? Amortization what? Period. Right? Okay. So what does it? It solves for either the number of payments, the payment amount, or the amount of a loan, right? Okay. The payment amount, interest paid, principal paid, and the balance of the loan are given for a specified period. Okay. So you can do this. Okay. Look at the arguments. This is the loan. N is the number of all payments. PMT is what? Value of what? Level payment. Nominal interest rate convertible, IC times per year. IC is what? Interest conversion frequency period. So it's, quite as if you have an idea what this is. And it gives you the formula for it. For example, the relationship between the effective interest rate and what? The nominal rate. Okay. So, and then it says what? It returns a matrix of input variables calculated on known variables and amortization figures for given period. Okay. So how do you use this? Well, they've given also an example. So this is a loan. Number of repayments period is what? 5. Interest rate is what? 1%. The time, T is the what? The time of payment is what? 3%. And you run this, you will get your what? The output in a matrix form. And so forth. So it's quite straightforward how these can be used. However, another, I need to comment on it, so let me go back to R and make sure, remember if you need to use this, you must first what? Okay, can you switch the fan off so that we can pull it back? I think it's the second, top left, second from top left. Okay, so first of all, you need to what? You need to load the package, right? That is the same as using what? Library, right? Okay, so another way, we've talked about buyers and MSC, so please make sure you can do that. This is the last topic that I think I'll talk about. Okay. So using packages from actuarial science. Okay. Using. Whoa. Why is it doing? But it used to have. I think it's broken. No, the what? Now it's little is everything. Okay, it has locked over there by any. So you leave it, we will just. Okay, so let's move on. Maybe when I even shout it will go. Okay, so using no, we should just say packages in actuarial science. Now I can't shout anymore. Because if I shout, it will go up. Okay. And today's date is what? I think, is it 10th? Or 11th? It's 11th, okay. Okay. So now, we said the first package we are looking at is what? It's financial man. So one, financial mass package. Or financial math. Okay, so I'll go back here and go to, well, let's see this example, the amortization table. So if you want to use that, you do amort, then, it's the table, you can have the table, you can have the period. So let's take this example and see what happens. There. So it gives you a table. The loan amount is 100,000. Payments, the level payments are 20.6. Effective interest rate is 0.1. Years, of course, at time 3. Okay, because we actually gave it N is 5 and then T is 3 and what have you. What else? The balance at the end. So this loan is not paid completely, right? At the end of the 5th year, you still have some amount left to be paid and so forth. So, but what I want us to also look at for is the functions, right? So if you take this and you check the annuity formulas that you use, you will find all of them in there, okay? And so forth. This is quite long, so I won't ask you something like this to replicate, but I can ask you the easiest ones, just to know that you can apply. So let me go back to the investments. So there are even stock pricing in there, right? Bond analysis. So Black-Scholes, I'm sure you've done the Black-Scholes equations. Or, isn't it? Are you sure? I don't believe you. So you use that to price stocks, and they actually won a Nobel Prize for it. So it's quite a famous blacks, maintenance. So when you do financial math, these are things you can't run away from. Bonds. I'm sure we all know what bonds are. Okay, so bond analysis you can also do so with this package. But let's go to 20, 23, 28. Okay, so 28 talks about internal rate of return. Now, how do we find the internal rate of return? For if I give you this, how are you going to find the internal rate of return? What is it in the first place? When we say internal rate of return, what do we mean? No one. But what about the net present value? Yes. What about net present value? Oh, my friends, you've done this in your financial math. Speak up. When we say net present value, what do we mean? No one. Oh, we should assume that you know, then we move on. You went to write exams on it. I can even look for your financial maths exams here. And because you don't want to, I have even forgotten that I have it. So you can't tell me that you have not done this. Yes. I have not. That is Act 2 what? 203, isn't it? So if that's what you are doing, I'll go back and take some of your exams questions. Then you implement it in R. This is what you did last semester. So let's see. Is that not what we are talking about now? And you are pretending as if you don't. This is about a loan. What? It's for the current 200. So if I go back to 2022, I'll find you. Okay. Yeah, but I mean, basically that's it. Find the interest rate, semi-annually, and so forth. And you will do all these annuities, what have you. Look at all this. My friends, you can't run away from this. You even do bond. So I'll ask you some of this in your exam. Okay, so let's move on. Okay. But Remember that here we've talked about you putting in money and then getting some out of it, right? But if this is 2024, or let's say this is 2024, this is 2025, 2020, and so forth. So when you go, the bank will give you this. Now this is what we are going to give you for this investment, right? Or you want to set up a poultry farm. So you hire a consultant. Then he says, well, this is maybe in thousands. So in the initial stage, you need 1 million, which will involve buying land, getting the structures built, and then also acquiring what? Chicks and so forth, right? Veterinary employees and so. So it will cost you 1 million. Now, if we're able to do it within a year, they will start laying, so you get 500,000. Okay. Then this is first year. Second year, they will start laying. The rate at which they lay will go down. So maybe within the year you get 200,000. Then the third year, maybe you need to sell them and get new stock. Right? If you do so, you end up with putting in 300,000 back into the business. So then you need to decide whether this is what a viable investment to do or not. How can you do this? We say we can use net present value. What does it mean? And the inflows. Is this just a difference? So I can add this. Yes, you need to find the present values. Okay. So it's the difference between the present values of what? Your inflows and then that of what? The outflow. Is that okay? All right. Now, the internal rate of return is defined as a rate. Remember, if we are doing a net present value, we need the rate, and let's say we take the treasury bills rate as an interest-free rate, right? Now, we can also let these cash flows determine the rate at which, this cash flow occurs over the years. So it means we will not go to the market and check the rate. The same cash flows, you use it to get the intrinsic rate at which it is given. Now, when you get that rate, of course, if it is greater than what is on the market, then the investment is good. If it is less than the treasury bills rate, then you are better off putting your money at the treasury bills and then get your interest. Is everybody okay with this? So the net present value, we will check if it is positive, it means we gain. If it is negative, it's a loss. If it is zero, what does it mean? So it is all, you break even. Is that okay? But under the present value. So you may realize that you are getting money, but if you factor in the discounting, it's not any money. Okay, and so for remember those discounting, you can actually include inflation as well. Is that okay? Yeah, and so forth. Yeah, but as I said, this is not really financial math class, but you should be able to use how to do some of the basics. So in this, I choose this, that the investment you should be able to do. So I'll ask you questions like this. Okay. Now, so we know what the IRR is, what the net present value is. How do we do this practically? Well, you can calculate this. If I tell you that the treasury bills rate now is, let's say, 9%, you'll be able to find negative 1,000, of course, will be what? 1 plus r raised to the power 0, so that's just 1, right? This one will divide it 1 plus 500 divided by 1.09, right? The other one will be squared, cube, and then we can go on and so forth. Okay, so but how do we do this in R? Let's go here. So it tells us that, here. Okay, so we have the IRR, and then of course the net present value. Okay, so let me go. The net present value NPV, it says what? It calculates what? The present value for the series of cash flows and provides a tree diagram of the what? The cash flows. So what I did, something like this is like a tree diagram, right? For the cash flows. So how does it, you need CFO. What is the CF0? Is the cash flow at what? Period 0. What is that? So that's this one. Please, are you with me? So CF0 is the cash flow at time 0. That's the beginning. What we put into the business. Okay. Then CF is a vector of cash flows. So it means that if we want to do this, we must take this as CF0, and then we take the other three as what? The cash flows. Is everybody okay with this? Okay, good. Then the times, vector of what? Times for each cash flow. Okay, so it means that this cash flow will be that one, right? So we'll have 1, 2, 3, up to what? Up to 3. Then the interest rate per period. Remember, net present value, you need interest rate to compute it. So we need an interest rate. And then plot tells whether to plot a time diagram of what? Of the cash flows. So what is the net present value? It's like this. Okay, and so forth. Okay. Yeah. So can you try? So this example, if you look at it, it means at the beginning of the investment, the person puts in 100. The first year, so that's the first. The second year, you don't get anything. So it's like third, fourth, you don't get anything, and then the fifth. Is that okay? So that's how that one looks like. Okay. Then this is just 2, 3. So you have at the beginning 100, then the cash flow is only 50, and the times are only the third period. Which means when you invest, you only get 50 at the end of what? The third period. Is that okay? All right, okay. So we can look at this and see how our output, and then we can now do our own. So this is the output, is negative. So what is your decision? What should be your decision? Is the investment viable? No. Good. Okay. Let's see how the plot is done. What's the argument for that? Is plot is equal to true. It doesn't look good. Okay, so let me do it again. Who can explain to me why I'm getting this? Can you guess why the graph is not visible at all? It's because I have increased my font size so that you will see. So when it comes, you have and then the graph too was like this. The plotting area looked like this before. So it was small. Okay, so you have to take note of some of these things other than that. Yeah. So if I want to do this, I need to go to zoom out so that so maybe you will find it quite better. But if I do it, you can't see it from here because the fonts will be very small. Have you been able to get a diagram nicely shown? Good. Okay. So just like we were saying, so 0 you put in 100, the first year you don't get anything from the investment, the second year you don't get anything, but the third year you get what? As I said, in samples you will see this arrow representing the. Is everybody okay with try what is on the board? Yes. Plot it and let's. So please try and explore all the things you are doing, from statistics to actuarial science. Check packages that you can use it for and explore them. You never know when an opportunity will come your way. So if you have any incentives and we are doing it, you can actually take the data and the values and write a report with all these diagrams to show. Which means you should, I mean, at the very minimum, you should know how to use PowerPoint, right? But it is better from your point of view to learn it. You can teach yourself to do it so that you can write reports, also presentations like that. If you go for intentions and you go over there, then they will report to the stage. I was in last year or two, I had a story that is still, I was there to do it. It was extraordinary. Always another way to do the thing. I wanted to say, please explore, especially when you are on vacation. At this time, you are going to write it, and so nobody will expect that you do it. But when you go on vacation, make sure you do that. Not just as because it's the exposure, so you can write 5, 10, SARS, so that by the time you finish your undergraduate, you know things are easy. So if you think you have an organization or you go and do your practice and it starts SARS, you have no enough information to cover. Have you been able to do it? So I can actually attach the times, but this one I'm assuming that it's just for 3 years, right? Each year you get something. But I can put it 0, and then maybe I should extend it. So 0, so 4 is 0, and then you get 400. So let's do it this way. Yeah. So you get 0 and then you get. then you implement it. So this one, what is the net present value? This one. This one. So it's minus. After getting, okay, yeah, because you put in, yeah. So still your decision is to what? Not to look. Okay. So now please study the health file for IRR and see how you can use that to also compute the internal rate of return. And then when you are done, you can compare whether they give you the same or as a matter of fact, in some cases you can have IRR says better than the internal rate of net return value is. Don't go and sit at home. Let's vacation. You go and sit at home, then when you come back, you say, I want to you do it in the you should look around. By this time, you've done so many courses. How can you apply some of this to solve problems that will come or start companies and that's all you can do. So before you sit down to do, you know the problem, you've done some research. So just be start. And you work in group. Okay, so what about the IRR? How do you, what are the help out? Also remember that I can ask you to write your own function and compare it with the output from R. Is that okay? So that is key. In R, if you know how to write functions, you are, I mean, it's okay for you to be able to work around. Okay. So IRR, the function is what? IRR. So you can look at it here, or you go to what? The package, the vignette for the package. So it also calculates the internal rate of return for a series of cash flows. Now, from what you know, when we want to find internal rate of return, how do we find it? In maths, it is equivalent to doing what? If you are finding internal rate of return, what is the mathematics behind this? That is financial mathematics. I want the raw mathematics. You are making R the subject. Percentage? No. What else? You are doing what? The NPV to 0. So what are you doing in that case? And you make rate the subject. So what is that? It's not change of subject. It's all. Yes, you are actually trying to find the zeros of a function. Is that okay? Yeah. So just like let's say we did maximum likelihood, it's the same concept. You want to find the zeros of a function. Okay. So if you look at the IRR, you can you will see what functions they use. I think it should be unique or unit root. Yeah. So once you know that concept, you can go in and check what. Okay. So this is polyroot. Remember, it will be a polynomial, right? This one, when we do it, you get the longer the cash flow, the more you get polynomials you get, because the discount factor will be raised to the power the time, right, as you move on. So the more the time, if it is 10 years, it means you are solving a polynomial with what? X to the power 10. If it goes to 100 years, then you even have more. And the more the power of the polynomial, the more roots you have. So that's why it is called polyroot and so forth. So if you know what it is about, when you look through the function, it should tell you what the rest are just things to make sure that you don't get an error. So for example, you stop if the plot must be of length 1. For example, if you go and plot, you give it true or false, it doesn't know which one to choose. So something like that. So all those things are just to make sure that any value you are passing through or argument is actually the required one. Okay, before you come to the actual computation, which is really this part, the polyroot. Yeah. Okay. So let's see. Let's still go to the help files. We have the usage. So you have IRR, CFO, CF times plot is, by default, plot is false. So it says CF0 is or cash flow at period 0. CF, so it's basically the same. Yeah, the same thing. Okay. So we can copy this, and then instead of NPV, what do we put there? IRR. Now, what do you expect? Oh, this is not the one that you did. This is not the one that you did. This one shouldn't have I. But this is from the, yeah, so this is, I'm still not getting my graphs correctly because of the size, but if you do it, you'll get it. Okay, so if I look at what you were doing, it will be, so you help me. In this example, CF is what? 1,000, okay. And then our CF0, okay. What? 0 and 400. And the times? 1 to 5. So I can just put 1 to 5 like that. And then plot is true. Okay. And did you get the same thing? Okay. So you can't really see it from here. Okay. Okay. So what is your decision? What's the decision? You go in for the investment. Why?
Because this rate is higher than the rates
we use what?
0.01.
0.01. Okay. And then this rate is what?
0.77.
But when the internal rate of return is higher, you invest. I'm sure this is percentage. Yeah. the output should be percentage. So it will then be 0.007. Yeah. Let's see. Multiple answers maybe. Yeah, so this should be percentage. Yeah, so it's 0.71%, which is lower than the other one. Okay. What else? Okay. So that's it with this NPV. Please go through it and explore. Is that okay? Are you okay? Okay, good. Now, and you must know the principles. I said I'll ask you. Okay. And please make sure that you can write a function to do both. Either net present value or what? Internal rate of return. Okay. Now let's look at another. So second, let's look at actual. I think we've used rings as well, right? So we are just exploring some of these packages in actuarial science. Okay, so actual, if you go there, that's actuarial functions and not heavy-tailed distributions. So we can click on it and then go in and study some of them. So there's aggregate.dist. There are distributions in this, moments and moment generation function, the coverage, conditional tail expectation. Do you know what a value at risk is? Value at risk. Okay, so in statistics, value at risk is just like a quantile. You know what a quantile is? I've talked about what quantile is. Okay. So remember that when we want to find the quantile, we equate or the CDF to some value, right? Okay. So that's your level of confidence for such, So if f of x is equal to, let's say, 0.95, we are talking about 95%. Then we can find s corresponding to that. Remember in your last example, you talked about exceedance probability. What is the probability that it exceeds this, right? Okay, so that x we calculate relative to the p or the 0.95 is what we refer to as a value at risk in actuarial science or finance. Is everybody okay? Yeah, but that is unconditional, right? What the value at risk tells us is what you can lose within a specific horizon, right? With some degree of certainty. Okay. Now, we can also say that what is given that, so this is a conditional, given that the loss is, let's say, over 100,000, okay, what is the probability that it will exceed, let's say, 200,000? Okay, so that it is conditioned on the fact that it is beyond 100,000, which means if your value is 50,000, you don't even get beyond the condition to even calculate the expectation again. So that's basically what a value at risk is. So the conditional tail expectation is a VAR with a condition that it is actually greater than a particular, so it exceeds something. There are some data sets in this. So this is actually is a package that is what? Dual package. It contains functions as well as what? Data sets. If you remember when we started with this, I talked about packages, right? So packages, some will contain only data sets, others contain only functions, and others contain what? a combination of what? Functions and data sets. So actual is one of them. Okay, all right. And these are just distributions. So the Feller Pareto distribution, dental is just claims data. Okay. So these are some of the data sets you can also use for, let's say, your projects, because these are real data sets with references. Okay. So yeah, and then inverses of the distribution. This is also a good thing. Remember, when you are doing probability, you talk about continuous distribution and discrete distribution, right? Okay. Now, in some cases, when we have a continuous distribution, you can discretize it. Okay? So just like, let's say, when we have a continuous variable like age, and we are able to break age into what? Categories, so that you have, let's say, 0 to 9, 10 to 19, and so forth. When we have a continuous distribution, we can also discretize it. Sometimes you do so that it takes into advantage of what? Some of the characteristics of the continuous distribution. So I had a student who is a PhD student now. In the master's program, he was looking at what was it? Was it accidents? Yeah, I think it was accidents, right? And you see, when we are, if you go for, let's say, the crime statistics, not crime, but accident statistics from MTT, that will be counts, right? So they will tell you that within this month, there were this number of accidents. Within the next month, there was. So if the year, usually you can have graphs stating what? The number of accidents. So that is count data, right? Okay. But our interest was to look at real accidents in relation to the cost, right? So in this case, we use a distribution from extremes, okay, which has tail, it's a heavy tail, like the Pareto. But now we need to fit that Pareto to what? Count data, which is discrete. So what we needed to do was now to discretize this distribution so that you can have it in a form that is like a Poisson distribution and so forth. So that's what some of the application of these stuff. Okay. So you can go through some of this to get to know some of the functions that are in these packages, some of the data sets that are available, distributions, and what have you. Okay. So that's it with the actual package. Then there was another package we looked at. We've gotten some function from it, which is rings, right? I can ask you about packages that you can use in actuarial science, okay? So please take note. It is important that within the field that you are, you get to know packages that are available to do some of the things actuaries do. Okay, so this one is functions for what? Reinsurance. Okay, what is reinsurance? Reinsurance is a reinsurance company. It's what? What is the concept of reinsurance? So how does it work? How do you implement that? No, in practice. Let's say I'm an insurance company. How do I implement a reinsurance, let's say, policy for the year? You insure the company. How? You go to so how does it work? How does it work? It's like only a few people. Well, okay, so let's discuss. You are teaching me how to set my questions. Yes, yes. 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 Good. So there's something that is missing. So will every claim go to the reinsurance company? Which one will go? I heard something. Large how? How do you determine that it is large? No, there's a criteria. You are not mentioning it. How large? No. So let's talk in practice how these are done. You went for internship, you couldn't ask all this. Or you only talk about the book one. Yes. That's all. To the company. But there is a criteria to determine whether a claim will go to the insurance or it will stay with the insurance company. And that's the exercise you were doing in the one that you are just having now. I asked you of exceedance probability. So there's a line. There's an amount that you say, well, they also will study your claims. And then you say, well, if it is beyond this amount, we will take this. And then you take the other part. So the insurance company, reinsurance, do not pay for all of it. They pay something. Then there's, what do we call it? Is it retention level or whatever? The what? I always forget this thing. I would take my travel insurance. You will see that they will say it has to be beyond 50 euros or something. So if you go to the hospital, the 50 euros you have to pay. But anything beyond that, then they come in. That's form of insurance, something like that. Okay, all right. So this package is for reinsurance. So when you go in, you will see some of the things you expect. So Quanta plus, remember we can have censoring. You said you are doing survivor or next, it's level 400. The survivor analysis. I think it's 400. Okay. So here, because we are talking about some large, you will see distributions that are skewed, okay? So for example, you see the Gen Hill. It is an estimator in extremes. So, you know, every distribution, we can estimate what we call the tail index. The tail index tells you how large or how wide, if you put it that way, or the tail heaviness of the distribution. That's the right way. Okay. So the C Gen Hill is for the Hill estimator, but in the case where you have censored data. Okay. GPDMLE, the generalized Pareto distribution that you use a maximum likelihood estimator to estimate the parameters like that. Okay. We've seen the log normal QQ, so you can have it for censored data and so forth. Pareto QQ, we've seen it earlier, right? And so forth. So Quanta level return, EPD. So these are in extreme value theory or statistics of extremes, most of them, because reinsurance is usually an extreme cases. So this is my research area statistics of extremes. Okay, so you will see that most of these things will be beyond what you know. But as you move on to do masters, these are some of the things you can take up. Okay. Rare events, exceedances. So all those exceedances, excess of loss, premiums, and so forth. They are all, you get a threshold beyond this, that's an excess, and so forth. Yeah, so you can go on and explore all these. This is the Norwegian fire claims. That's a popular data in insurance, okay, that you find in so many publications. Yeah, so it's a data set that if you do some work and you want to analyze data, you can also use because it's widely cited in the literature. Okay, so that's it with this. There are several of them. Remember when there are those that are just data sets. There's, I think it was life insurance data or what? Is it insurance data rather? There's insurance data. That one is just a package that is made up of what? Just data. So you can check that if I ask you to install that one too. So is this. So insurance data is what? A collection of what? Insurance data sets useful in what? Classification in non-life insurance. Okay. So these are, when you go in, you see several data sets that can also be available to you for your project and subsequent. Okay. So yeah, so basically that's it. There are several of them. If you go to, do you remember how many packages there were when we started with this course? It was, I think, over 20,000, right? We can go back and check what is happening now. Here we can't see the number, so let me see, CRAN. No, I just want the CRAN page. Okay, then we go to packages. Okay, so in about 2 months, right? We started the class in 2 months and 2 weeks. So less than 3 months. You see now how many we have? 21,062. Is that okay? So packages are, always being added. Others are what? Being sent to what? Is it no quarantine? Archives, yeah. And I did go through how you can even get a package from archives, right? And install. You shouldn't be surprised if I ask you in an exam. Is that okay? You forgot it. Okay. Please don't forget anything we've said here, including those we have not said. Okay. So any question? Okay. I think there was one that I did not talk about. Life insurance, life contingencies. Life contingencies. I think that I don't really ask you questions on it, do I? I have to check the past questions to see whether I have no eyes. Otherwise, I will lie to you. It's not a lie, it's an oversight. So that you go to the exam and there is life contingency. You come and beat me here. Okay, so life contingency is financial and actuarial mathematics for life. Actually, some of the things, the IRR and so forth, you find it in this package as well, the life contingencies package. So please take your time, go through that as well. I can go through here for you to see. So here, you can do all your life contingencies. Okay? Um, um, life insurance, annuity, immediate, due functions, and so forth. All those things you do in life contingencies. Actually, you can have life tables as well from different parts of the world. The Italian one, the US one, and have you in this. Okay. Yeah. Yeah, so it can calculate present values, just like we did from the other one. It can do interest rate conversions from effective to nominal and so forth. You found that in the financial math package as well, and so forth. Okay, so that's it with our course. I think this is a good time to end. So I will encourage you to practice. Go online, check YouTube for some of our videos. I have, now that we are, I think I'm done with most of the things I want to do. I'll let you do an exercise individually at UGCs. So let's plan for next week, okay? So that now it will give me a level playing field to know whether people are actually or they are hiding behind others. Okay, so either Thursday or Friday we should go there. It will be a quick exercise. So this one you have to say what it is called. Because if I say use a function to do this, you still need your data. Your data. So yeah, I mean basically everything. So you do an exercise just like you've been doing. But I want to see that given that you are not with your laptop and so forth, you'll be able to do some of these things. We can let it serve as your eye. Do I give past questions for this? You may find some. But I have given you one. The one that I gave you, I think I asked in an exam. What is it? The exercise you did. Yeah, so the exams is like that. I can show you some. These are people who have cameras here. Isn't it? And now they are reaching out for their phones. Oh, you are what? I won't even remember the password. Okay, so I give it to you on Sakai, but when you go there, there will be a password, so that you don't sit somewhere and do it. So many things go on over there. During the COVID, we were there, invigilating, not knowing somebody was doing it somewhere. You people, we know you from... so, yeah, so it's something like this. So usually you have to create a folder. There are instructions. Just take your time. Go through it to create a folder, so you have to save your workspace. By now you know what workspace is. What is a workspace? Which one? Is a workspace. The project directory. You are there but not quite. That's your working environment. When you save, remember we went to sessions, save, then it takes you to the working directory. But when you close it, it will ask you to save. When you save, then you have your out data. That's your workspace. Yeah. So sometimes you may have problems with computers and so forth and what have you. So I encourage you to save all what you did. If there is a problem, I can send you back to UGCS and then you retrieve it. Okay, so I encourage you to do, when you go, it will be there. You will never, some will send and then you open the PDF, there's nothing in it. Or the PDF is corrupt, you can't open. Or the Word is corrupt. So I encourage students that, you know, so you see Word, PDF, do all of them, then you upload. Okay, if one is not working, sometimes I have to call people during vacation, and some, I mean, by that time, your script, whatever, maybe they've deleted it. Yeah, and so forth. So please be careful when you are doing this. I don't really take excuses, because this is practical course. I have to make sure that you actually know what we have done. So when you come, I'm just issuing my disclaimer so that you don't even come. When it comes to this exam, please don't come, because I won't listen to you. Not that I'm wicked or whatever, but I need to make sure that, and students can always, you are looking for corners to pass through. Okay? Because this one is time consuming, but it is good for you in the future. So if we don't put our feet down, and, I mean, when you come, just as I am, everything I will take it, then I take it, you won't learn. And so I beg you, when you have problems, if it is genuine, I mean, I'm open. But I went home, I was sick, and so those things, you let me know before. Don't let us finish and then you now come and tell me. When you are sick, you go to the Legon Hospital. If we are writing exams, you tell them that you have exams. We can bring you the paper there. And that one, there's a doctor there. So if you collapse, they are there to help you. That reminds, so don't go to the exam center when you are sick. You are worrying yourself. Okay? Just go to the hospital. Once you say you have exams, they will send you to the exam center there. And they will come for it. They even give you extended time. I mean, when they come, when I was a chief invigilator, when they come, even 1 hour, I'll give you the full time. Because I have to decide. You are not well. So I said the person has not started. The chief invigilator will even be fighting me, but he knows that. Anytime there's a sick student from my end, it's always, hey, Dr. Mika, as for you, nobody has spent any time there. But that's what I do. So when you are sick, go there. Okay? Don't go to the exam center. Because, you know, if we want to go by the rules, we have to subtract what you have done over there from the time. But I mean, sometimes for me, I just look at it this way. This one, 1, 1, 1, 1, 1, 2, when you fool around, I don't really mind. But this one, you can't fool around. So please, if you don't know, and it has to be, I usually, don't even fail students at the start, but I realized that students were not taking it serious. Because what I was doing was that, these are assignments, so all the assignments that you are doing, I'll put them together, making 50% of the marks. Then what I think everybody, I give you a fair, everybody has a computer over there. At first, you were even sending your laptops. But students, the person will send an email to somebody somewhere. All those things. So we said, well, no laptop. Even the master students now, I don't, allow them to do so. So at first it was easy for us, because when you go there, there's not much pressure on the UGCS. Even when they are having, the receipts I can send you. But those are some of the things to them. So the person is there, but not there. The exam is taking place at another place. Okay, so now we say no laptops, right? You go there, we give you the questions, and then you do it there. Okay, don't attempt. Okay, because they will see it. Okay, if you are there, you open Sakai, and you are, Google. Now there's ChatGPT. So they monitor it, and then they alert us. So for me, as soon as I see that, I don't want to report you so that they sack you. You repeat the course. That's it. That's all I'll do. So that one, if you say I'm wicked, no. The last time I saw one of them. So I was going to 37, and then I think I parked somewhere. Then I was crossing the road. Say. And I said, "Where are you now?" I said, "He's doing national service." And I knew that I repeated it. so I thought maybe he would be angry, but he thanked me. Yeah, that's what we want to see. So if I'm doing that to you, it's not that I'm wicked, but I want to make sure that when you go, and he said he was at GCB, and he now thanking me that, I mean, he would have gone through it like that without knowing anything, because they copied. If I forgot to tell you, this exam, when you finish, you go and print and bring it to me. It's all part of the training, right? Okay, so just be sincere. Whatever you did is on Sakai, bring it. I always tell you that for me, if nothing at all, if I don't have time at all, I taught you statistics, right? Even level 100, we talk about sampling, right? So we will put it into practice. So if I can't do check, all the TAs are there, I can download all your files, then I give it to them, check whether it's the same. We catch some all the time. Okay, I needed to repeat some of them. Was it 400? I think this one, and 240. Yeah, so that's what, please be sincere. I mean, when we even go for moderation, we even beg for you to be passed, right? So nobody is here to fail you. But when the things that are practical, that when you go out, you can demonstrate for you to get job and other things, I won't compromise. So please, I have issued my disclaimer now. So I don't expect to see anybody coming there to beg. Is that okay? Is that okay? And I hope you understand me on this. If you don't, so you see that I said I can ask you something on packages. Okay, so these are types of packages and so forth, just to see that whether people are, taking notes and other things in class. So then I give you a preamble. So this is something we've done in class. I just asked you. So there's a package for so and so. In the preliminary search, you came across so and so that can compute the size sizes and so forth. I'm sure people are recording. They should record. I can send it to you anyway. Loss in extreme hence so and so. You remember the VAR that I was talking about? Okay. Now, so the question is here. So, however, the package was last updated in 2013 and hence not available in the Actuarial repository. So now describe how you will be able to install this. You should be able to do it. We've done this. Okay, so as I said, for this, unless you don't come to class and you are not taking part, it shouldn't be anything that difficult. We solved it in class, right? We've done this in class. Okay, so it's not the insurance so and so. What is it? Modify your function, obtain. We've done this. Plot phase and so forth. Then that year I gave them this. A truncated exponential. Don't say A. You will be able to. Because what if you know the PDF, all you have to write is a function for the PDF. Find the sum, right? Sum of the log. That's all. You have your likelihood. So write a likelihood function. Then obtain a data set and find, I'm sure you should be able to do this, 15 top order statistics. How are you going to find that? You do it. So we say that, you see, this is like what you did, the exercise you did. But now I say obtain your statistics and use the 15 top order statistics as your X node. How are you going to find that value? Look at somebody. You can record, I don't. As I said, I can send it to you. So, just that I caught him. Okay, so let's see. How? Yes. If I give you a data set and I say find the 15th top order statistic, well, how are you going to do it? You rank them, yes, and then from your ranking will be what? Descending order, ascending order. And remember, if you use ranking now, it will give you something else. Oh, but of course, you can use the rank to get the 15th value. Then you search. I mean, there are so many ways you can do this. So if you use the rank, it will rank each value at the position of each value, right? Okay. Then you can now say which rank equal to 15. And then if you pass it through the inside the square bracket, it will extract the 15 value. That's one. Alternatively, you can sort it. Then you take the 15th largest order or top order statistics. Okay, so it's up to you to explore. Remember, in R, which is a function, right? You can use which.max, which.min. And then you can use which to get the position that something occurs, and so forth. So you can explore some of those things. So, yes, you fit this to the sample in B. So it's not much of a problem. So this is also the cash flows problem. Okay. So in order to develop a new product and place it on the market, RM Group Inc. consulted you to do an investment analysis. The following table shows similar investment made earlier by the company. Assume risk-free rates and use it to answer questions. I usually will repeat something like this. So study either the financial or life contingency package in R and use the appropriate functions to compute the net. So it's up to you to use that. But B says write your own function to compute the net present value. Yes. Based on your results, is the investment viable? Explain. So this is like an example in 332. There's no choose. Okay. Please, are you okay? Okay. So basically, that's our discussion for this semester. So I'll let you meet. I'll get you more assignments, and but I want to know whether you can do the things we have done. So I'll do a mini test or next week. I'll communicate the day to you, either Thursday or Friday. But I'm sure the Thursday will work if they don't have anything. If you have any problem, you are always free to contact the TAs or come to my office, okay? If you are encountering any problems. Or feel free to come and seek assistance. Yes. That's all. I'll scan through and then upload all that. But there are counterparts. Most of the topics have been treated already. So the previous ones you can also watch through and see what they Please make sure you sign, okay?